Okay, so multiplying functions. We are continuing on with our operations with functions. We talked about adding and subtracting functions, so now we're moving on. Couple things that you do need to keep in mind, some vocabulary for multiplying functions. Today we are going to be talking about polynomials. Now, polynomial is a fancy kind of math word that just means algebraic expression with multiple terms. So in particular today, we're going to be talking about multiplying two binomials. So a binomial is specifically two terms. So if you look here at our example, we have 3x plus 2. So a term is separated by a plus or a minus sign. So right here, we have 3x, that's one term, and then positive 2, that's going to be our second term. So really important for today's work when we're separating terms, remember that they're separated by a plus or a minus. Okay? Now, moving into kind of the organization of what we're doing today, we're going to learn a particular method today for multiplying polynomials, and it's called the box method. There are multiple different ways to multiply polynomials. You have FOIL, you have box method, you have double distribution. There's lots of different ways, but the one we're going to focus on today is called the box method. And one thing to keep in mind with the box method is when you're multiplying two things together that look the same, they make a square. Okay, so remember 3 times 3 is 3 squared. 10 times 10 is 10 squared. So very similarly, when you multiply x by x, that becomes x squared. This is a really important thing to keep in mind for what we're doing today, because students tend to forget that when you multiply a variable by the same variable, it turns into that squared, not 2x, but x squared. I have students make this mistake every year, and I don't want y'all to fall into the same trap. So that's something we're going to keep in mind during our lecture today. And when you see this pattern happening, where you see that we have x squareds, a squareds, r squareds, b squareds, when you see the patterns falling into place, remember, when you multiply a variable times the same variable, it's that variable squared. Okay, so box method. Box method is very, very similar to what you learned when you first learned multiplication tables. Okay, so essentially what we're going to do is we're going to set up a box. That box is an organizational tool. It organizes the way that we multiply things. Okay, so it's essentially, if you're in biology right now, I'm not sure if you guys have covered your like genealogy unit, recessive traits, dominant traits, your big G, little g, those kind of things where you have, you know, things like blue eyes or black hair, dominant, recessive. So when you are multiplying those things together, you use a box, right? It's called a Punnett Square. You're using Punnett squares. So that's very similar to what we're doing today. Okay, so our box is going to have 4 quadrants, so it's going to be kind of set up like this. Okay. Now, for the purpose of what we're doing today, we're going to refer to the side as the top and the bottom, and then we'll refer to this as the left and the right. Okay. So depending on what quadrant you're in, that's going to tell you what you're multiplying together. So for example, the top left is literally you multiply the top number by the left number. And then top right, you multiply the top number by the right number. Should say term. Okay. Now, moving to the bottom. So you have the bottom left. You multiply the bottom term by the left term. And the bottom right, you multiply the bottom term by the right term. It literally is telling you what you're multiplying together. So if you are in the top left box, you're using the top term and the left term, okay? Just like multiplication tables. So I want you to keep this in mind when we're going through our work today, because the box is an organizational tool. But if you don't know how to use the organizational tool, then it's not going to help you. So that's why we're going to do lots of examples today so that you can see these problems worked out. And you're going to see that there's a pattern here, repetitive pattern over and over. Okay, here's our method. So we're going to put one polynomial on the side and one polynomial on the top. We're going to multiply each piece like a multiplication chart, and then we're going to combine like terms at the end, and that will be our final answer. Okay. So we're just going to dive right in. We're going to get into our first example. So example number 1. Here are the two binomials that we're multiplying. We have x plus 3 multiplied by x plus 7. So it essentially does not matter where you put each term, but just to make things uniform, x plus 3, the first one, I'm going to write that on the side. So the top term will be x, the bottom term will be plus 3. Okay. Now x plus 7, I'm going to put along the top. So on the left-hand side, I'm going to put x, and on the right, I'm going to put positive 7. Okay. Are there any questions for how I chose to organize the box? Okay, now remember, even if I switch these, if I put x plus 7 on the side and x plus 3 on the top, it still wouldn't change anything. I get the same exact answer. So it doesn't matter where you put them, you just have to make sure that you organize the terms correctly. Okay, now we're just going to go through. I'm going to write what I'm multiplying in the box so that you can see. So top left is going to be top times left. That's x times x. And remember from the slide we talked about earlier, x times x is x squared. Okay, now we move on. Top right, x times positive 7. And that's positive 7x. Now we're moving down, bottom left, 3 times x, that gives me 3x, and one more, bottom right, 3 times 7, that gives me positive 21. Okay. So again, the location of the box is telling you where you are putting things and what you're multiplying by. So now that I have 4 terms, I'm going to write those 4 terms out. So I have x squared, then I have 7x, then I have 3x, and then I have 21. Now, hopefully you'll notice I do have some like terms here. The 2 middle terms are like, they both have 1x. So I'm going to combine those together, and my final answer is x squared, 7 plus 3 is 10x, and plus 21. Okay, and this is our final answer. Okay, so I know that at this point, this is our first example, but there's a pattern that we're going to see here when we get into more examples. Okay, so I want you to keep the structure of this in mind. Okay, look at the box. Okay, we have our top left, which is something squared. Then we have our top right, which only has 1 variable. Bottom left has 1 variable. And then the last square, the bottom right, is a regular number. Okay, let's jump into example 2, and we'll see if that pattern stays in place. Okay, any questions before example 2? Okay, let's jump in. So we have 2 polynomials here again, 2 binomials, 3x minus 5 times 5x plus 2. So 3x minus 5, I'm going to write on the side. Okay, top term will be 3x. Bottom term is going to be negative 5. Remember that minus sign, this negative goes with the term after, so that's minus 5 or negative 5. Now on the top, I have 5x on the left, and then positive 2 on the right. Okay, and now we're just going to jump into multiplying. So I have top left. That's 3x times 5x. So what we're going to do here is we're going to multiply number by number. That's 15. And then x times x makes it x squared. Easy peasy. Next box is top right. 3x times 2. 3 times 2 is 6. the single x tags along. Moving down to the bottom, we have bottom left, -5 times 5x. -5 times 5 is -25. The single x tags along. And our last square, we have bottom right, -5 times +2. That gives us -10. Okay, so the pattern is in place. We still have the same pattern here. We have x squared on the top left, and then we have x, and then a regular number. Okay, so let's write them down, our 4 terms. 15x squared plus 6x minus 25x minus 10. Okay, now your middle terms, you have x and x. Again, those are like terms because they both have 1x. So we combine those. Our final answer, 15x squared. 6 take away 25. 6 take away 25 is -19x. And the minus 10 tags along. And that's our final answer. So just like our first example, we went from 4 terms down to 3. The 2 terms in the middle always combine together. Very, very similar to the first example. So this procedural understanding, right? We're doing these over and over. They're essentially the same problem, just with different numbers, but the process, the procedure, exactly the same. The patterns that we see are going to repeat over and over and over. Okay, so with each example, you're getting better and better at doing problems like this. Okay, major questions, anything you want me to repeat? Okay, example number 3. This is our last standard example. So just like the first 2, at this point, you should be able to handle this example on your own. I'll go through this a little more quickly than I went through the last 2. And again, if you have any questions, please let me know. If you need me to slow down or explain anything, I can definitely do that. Okay, our first binomial, -3a. We're using a this time. Doesn't change anything. It's just a different letter. -3a plus 4. So on the top, I have -3a. And on the bottom, I have +4. Then our second binomial, 2a minus 1. So on the left, I have 2a. And on the right, I have -1. Okay, now we're going to jump into the multiplying part. So again, my first box, top left, -3a times 2a. -3 times 2 is -6. A times a is a squared. Now I move to the next box, top right, -3a times -1. -3 times -1, that makes +3, that a tags along. Okay, moving to the bottom. I have bottom left, 4 times 2a. 4 times 2 is 8. That a tags along. And then our last box, bottom right, 4 times -1 is -4. Okay, we write out our terms. -6a squared plus 3a plus 8a, and then -4. Again, the same patterns that we've been seeing repeat again. We have a squared, then we have 2 terms with just regular a and then a regular number. The 2 terms in the middle are going to combine together. So our final answer, -6a squared plus 11a minus 4. Okay? Remember, mathematics is a lot about finding the patterns, okay? And then the procedure will just reinforce those patterns. We're seeing those patterns over and over. Okay, We have done 3 standard examples. I have one more example for you. This example is going to look a little bit different, but the procedure is essentially still the same. We just have to make one consideration. So this last example is called a perfect square binomial. And essentially, it's just a different way of representing the same type of problem. Okay, so here's our last example. We have p plus 3 squared. Okay, so we just got to remember what that little exponent means. What does this exponent mean in terms of multiplication? So you just think back to what 3 squared means, right? That means 3 times 3. Okay, we have, negative 5 squared, and that means negative 5 times negative 5. So essentially what a square means is you just multiply the number by itself. So p plus 3 squared is just saying p plus 3 times p plus 3. It's a shorthand way for writing p plus 3 multiplied by itself. And as long as you remember that, then when you see problems like this, you'll know what to do. Okay, so this is exactly the same as the last 3 examples. Okay, it's just starting off differently. We have to just take that extra step and write out what p plus 3 squared means. So we have p plus 3 on the sides. You also have that along the top. And now we just multiply exactly the same way we've been multiplying for the last couple examples. So we have top left, p times p, that's p squared. Then you have top right, p times positive 3, that's 3p. Okay, same patterns here. We have a p squared and then 1p. Now we have bottom left, so that's 3 times p. That gives us 3p. And then we have bottom right, 3 times 3, and that gives us 9. Okay, so we write our terms out again. P squared plus 3p plus another 3p plus 9. The 2 in the middle combine together. So our final answer is p squared plus 6p plus 9. And that is our final answer. Okay, so